Dear students, welcome to all of you. Today we are here to discuss Salient features of classification system by Bentham and Hooker. First, the introduction. The science which deals with the classification of organisms is called taxonomy, a term coined by the famous French botanist A.P. de Candolle in 1813 and which stems from two Greek words, taxis meaning arrangement and nomos meaning study. The term taxonomy is sometimes taken as a synonym of systematics. According to the paleontologist George Gaylord Simpson, systematics is the scientific study of the kinds and diversity of organisms and of any and all relationships among them. There are four components of taxonomy, that is description, identification, classification and nomenclature. The description of a taxon is a statement of its attributes and characteristics and is obtained from the thorough and careful examination, observation and study of the plants. In taxonomic procedure, description and identification precede classification, which precedes nomenclature. That is, description cum identification is the basic process in taxonomy, which involves determining whether an unknown plant belongs to a known named group of plants, and there are three ways to achieve it. These include the help from a professional botanist or a well-trained naturalist who knows the plant of a region, with the help of floras or other literature, and the herbaria. On the other hand, nomenclature is the assignment and application of scientific names to the already identified and classified plants. Classification is the placement of an entity in a logically organized scheme of relationships. It is, in fact, the formation of ordered groups and subgroups of a particular lump of objects such as living beings. The first to write down a classification of plants in a permanent and logical form was the father of botany, Theophrastus. Contributions of the Civid, Carl Linnaeus, usually latinized as Carolus Linnaeus, to the science of taxonomy are so vast as to entitle him as father of taxonomy. He popularized and customized the binomial system of nomenclature that has already been proposed and designed by Gaspard Bahen in 1590 but not followed with consistency. The history of taxonomy has no horizons, as it had its roots in the origin of human species and civilization, with glorious past, present, and more so a future is anticipated. Classification has been actually a need-based practice, and hence the classificatory systems are transient in nature. They continue to be modified and improved as a result of new findings. Davis and Haywood in 1963 in their book entitled Principles of Angiosperm Taxonomy have quoted Tyndall Hopwood saying as, "The urge to classify things is a fundamental human instinct. Like the predisposition to sin, it accompanies us into the world at birth and stays with us to the end." All modern systems have a past and are essentially modifications of the earlier ones, and historically, plant classifications belong to three categories. These are artificial classification, natural classification, and phylogenetic classification. Dear students, now we will discuss the salient features of classification system by Bentham and Hooker. The last major and the most accepted natural system of classification of seed plants was that of Bentham and Hooker. It is a natural system of classification and is based on important characters of the plants. Even today, this system is being followed in India, United Kingdom, and several other Commonwealth countries. It is also used in a number of herbaria and botanical gardens all over the world. It is a well-known and widely accepted classification of seed plants. It was proposed by two British botanists, George Bentham and Sir Joseph Dalton Hooker. They were associated with Royal Botanical Garden at Kew and adopted a very comprehensive system of classification which is purely natural and most convenient and extremely suitable system for practical utility in identification of plants, providing them their respective taxon. This was the greatest taxonomic work ever produced in the United Kingdom and has ever since been an inspiration to generations of Kew botanists. Their system of classification was published in Genera Plantarum in 3 volumes, and they had described 97,205 species of seeded plants in 202 orders now referred to as families. This 3-volume monumental work, which required quarter of a century, comprised description of all genera of seed plants known to science at that time, and they were classified according to the system proposed by them. This system was published well before there were internationally accepted rules for botanical nomenclature. It indicates a family by order. An order is indicated by cohorts in the first 2 volumes or series in the 3rd volume. In the first 2 volumes, series refers to a rank above that of order. The system of classification by Bentham and Hooker is based on groups of plant characters which are correlated with each other. For example, if a specimen consistently shows syngenesious stamens, inferior bicarpellary unilocular ovary with basal placentation, then it can confidently be assigned to the family Compositae. Basically, the classification system of Bentham and Hooker is on the same basis as that of the de Candolle, but with some modifications such as greater emphasis on the free and fused condition of petals. This system includes the names and descriptions of all genera of seed plants known so far and classified accordingly. They divide seed plants into 3 classes in sequence: Gymnosperm, Dicotyledon and Monocotyledon. Dicots divided into 3 divisions and 14 series on the basis of the natural and visual characteristics which provides key for identification. Dicots started with family Ranunculaceae having free sepals and petals and indefinite number of stamens and carpels, whereas it ends with Labiatae having fused sepals and petals with definite number of carpels and stamens. Among monocots, out of 7 series with epigynous flower, that is Orchidaceous and Cytimini, were kept first and second respectively, followed by with petaloid hypogynous flowers, and finally ended with Gramineae and Cyperaceae. Now the outline of classification system by Bentham and Hooker. The Bentham and Hooker divided seed plants into 3 classes: Dicotyledoni, Gymnospermi and Monocotyledoni. Class first, Dicotyledoni or Dicotyledonous. Seeds of Dicotyledonous plants contain 2 cotyledons, stem with open bundles. Leaves show reticulate venation. Flowers are tetramerous or pentamerous. It includes 3 subclasses: polypetally, gamopetally and monoclymedy. Subclass first, polypetally. Plants having flowers with free petals come under polypetally. The flowers are with distinct calyx and corolla. It is further divided into 3 series: Thalamiflorae, Disciflorae and Calciflorae. Series first, Thalamiflorae. It includes plants having flowers with dome or conical thalamus. Ovary is superior. Petals and stamens hypogynous, disc present. Thalamiflorae includes 6 orders and 34 families. The 6 orders are cohorts, and the number of families present in each order are: Order first, Ranellus, gynoecium apocarpus represented by 8 families. Order 2nd Parietalus, placentation parietal represented by 9 families. Order 3rd Polygallinae, ovary with 2 to 3 locules represented by 4 families. Order 4th Caryophyllinae, axial or free central placentation represented by 4 families. Order 5th Gutyphirales, staminous numerous calyx imbricate represented by 6 families. And order 6th Malleolus, staminous numerous calyx valvate represented by 3 families. Series 2nd Disciphyllary. It includes flowers having prominent disc-shaped thalamus below the ovary. Ovary is superior. Disciphyllary is divided into 4 orders and 23 families. Order 1st Geraniolus, Ovulus pendulus, raphe ventral, Androecium diplostaminus represented by 11 families. Order 2nd Olaceolus, Androecium diplostaminus, Ovulus pendulus, raphe dorsal represented by 3 families. Order 3rd Celestralis, Androecium haplostominus, Ovulus erect, raphe ventral represented by 4 families. And order 4th Sependalus, Androecium diplostaminus, Ovulus ascending, raphe ventral are inverted and represented by 5 families. Series 3rd Calciflory. It includes plants having flowers with cup-shaped thalamus. Ovary is superior or inferior, sometimes half inferior. Calciflory includes 5 orders and 27 families. The 5 orders are cohorts of Calciflory, and the number of families associated with each cohort are: Order 1st Roseolus, staminous indefinite, often twice or more the number of petals, stylus distinct, represented by 9 families. Order 2nd Myrtillus, staminous definite, rarely indefinite, flowers epigynous or perigynous, represented by 6 families. Order 3rd Passiflorellus, placentation parietal, represented by 7 families. Order 4th Fucoidealus, perianth undifferentiated, placentation basal or axial, represented by 2 families. Order 5th Umbellus, inflorescence umbellate, represented by 3 families. Subclass 2nd Gamopetalae. Plants having flowers with petals which are either partially or completely fused to one another are placed under Gamopetalae. The sepals and petals are distinct. Gamopetalae is further divided into 3 series: Inferi, Heteromeri, and Bicarpellate. Series 1st Inferi. The flowers are epigynous and ovary is inferior. Inferi includes 3 orders and 9 families. Order 1st Rubiolus, staminous epipetalous, anthers distinct, ovary with 2 to many locules, each with 1 to many ovules. The order Rubiolus is represented by 2 families. Order 2nd Astraeolus, staminous epipetalous, anthers distinct or united, ovary unilocular with 1 ovule, represented by 4 families. Order 3rd Campanellus, staminous not adnate to corolla, ovary 2 to 6 locular, loculus many ovuled. The order is represented by 3 families. Series 2nd Heteromeri. The flowers are hypogynous and ovary is superior with more than 2 carpels. Heteromeri includes 3 orders and 12 families. These are: Order 1st Ericalis, staminous double the number of corolla lobes are isomerous and alternating with them. The order Ericalis is represented by 6 families. Order 2nd Primulellus, number of stamens is equal to number of corolla lobes and opposite to them, ovary unilocular, represented by 3 families. Order 3rd Ebenellus, stamens as many as corolla lobes and opposite to them or many, ovary 2 to many locular. The order Ebenellus is represented by 3 families. Series 3rd Bicarpellate. The flowers are hypogynous and ovary is superior with 2 carpels only. Bicarpellati includes 4 orders and 24 families. The 4 orders or cohorts of Bicarpellati are: order first, Gentianales, leaves mostly opposite corolla actinomorphic, represented by 6 families. Order second, Polymoniales, leaves mostly alternate corolla actinomorphic, represented by 5 families. Order third, Personales, corolla zygomorphic, posterior stamen often reduced to staminode, ovules often more than 4, represented by 8 families. Order fourth, Lamellus, corolla zygomorphic, posterior stamen reduced, ovules 4, represented by 5 families. Subclass third, Monoclymedy. Plants having flowers with single whorl of perianth are placed under monoclymedy. Flowers are incomplete. The sepals and petals are not distinguished and they are called perianth. Tepals are present in 2 whorls. Sometimes both the whorls are absent. Monoclymedy includes 8 series and 36 families. Series first, Choroembry. Embryo curved, round the endosperm, ovule usually 1. Choroembry is represented by 7 families. Series second, Multiovulate Aquatici. Aquaticus with numerous ovules. It is represented by a single family of Podostemoniaceae. Series third, Multiovulate Terrestris. Terrestrial plants with numerous ovules. It is represented by 3 families. Series 4, Mycoembry. Embryo very small and copious endosperm. It is represented by 4 families. Series 5th, Daphnalis. Ovary usually with 1 carpel and single ovule. Daphnalis is represented by 5 families. Series 6th, Ecchymiospori. Ovary usually inferior, unilocular and 1 to 3 ovuled. It is represented by 3 families. Series 7th, Unisexualis. Flowers unisexual. The unisexualis are represented by 9 families. Series 8th, Ordinus Anomali. The families of uncertain relationship were placed in this series. The Ordinus Anomali are represented by 4 families. Class 2nd, Gymnospermy. The members of this class have naked ovules or seeds. Ovary is absent. The Gymnospermy includes 3 families: Nitaceae, Coniferae and Cycadaceae. Class 3rd, Monocotyledonous. These are usually herbs, some are shrubs, seed with 1 cotyledon in embryo. The Monocotyledonous includes 7 series. Series first, Microspermy. Ovary inferior, seeds very small. Microspermy are represented by 3 families. Series second, Epigyne. Ovary usually inferior, seeds large. The epigyne are represented by 7 families. Series third, Coronary. Perianth petaloid, ovary superior. The coronary are represented by 8 families. Series fourth, Calycinae. Perianth cephaloid, ovary superior. Calycinae are represented by 3 families. Series fifth, Nudiflori. Perianth mostly lacking, ovary superior. Nudiflori are represented by 5 families. Series 6th, Apocarpy. Carpels free. The apocarpy is represented by 3 families. Series 7th, Glumaceae. Perianth small, scale-like or chaffy. The Glumaceae is represented by 5 families. From this classification, it is understood that if we proceed from the beginning, considering the morphological characters of a species, we can easily identify it and to place it in its specific taxon. Dear students, now we will discuss the merits and demerits of Bentham and Hooker system of classification. Not a single classification can claim to be perfect, satisfactory and free of criticism. This fact forms the basis for the wide array of classificatory systems from time to time. The Bentham and Hooker system is no exception, and a number of its merits and demerits have come to limelight. First, the merits. Bentham and Hooker's classification is the most natural system based on actual examination of specimens. The description of plants is quite accurate and reliable. As it is easy to follow, it is used as a key for the identification of plants in Kew herbarium and several other herbaria of the world. Although this system is natural, most of the aspects of this system show affinity to modern concepts of evolution. For example, the order Ranellus, which is the first order in the arrangement of plants, has been given a primitive position in this system. Recent taxonomic findings also indicate that the members of Ranellus are the most primitive living angiosperms. Each family had a synopsis at the beginning, which is very useful in identification. The gamopetally placed under polypetally is justified since union of petals is considered to be an advanced feature. Treating cucurbitaceae and umbelliferae at the end of polypetally as connecting links between polypetalous and gamopetalous families. Creation of monoclinidae at the end of dicots. Disputed families included in ordinous anomaly. Placing of unisexual monocot families after bisexual families, for example, Palmae and Araceae after Liliaceae. The series Glomaceae with extremely reduced flowers and inflorescences placed at the end of flowering plants. The placement of monocotyledone after the dicotyledone also appears to be in accordance with the evolutionary trends. The system was never conceived by its authors on the basis of phylogeny. The theory of organic evolution was announced independently by Darwin and Wallace in 1869, so any criticism of the system on the basis of phylogeny is not too justified. Now the demerits. The system does not give any idea as to the evolutionary history of any genus, family or order. In this system, grouping of plants is mainly based on single and artificial characters, with the result that closely allied families are widely apart. The group Monoclinidae is entirely artificial. The placement of gymnospermy in between dicotyledone and monocotyledone is an error. Several important floral characters have been neglected in this system. Advanced family Orchidaceae has been considered as primitive among monocotyledonous, and it is placed in the beginning of the system. In this system, some closely related families have been separated and placed under different groups. For example, all the families of series Caroembri of Monoclinidae are related to Caryophyllaceae of series Thalamiflorae of Polypetalae, but they are separated. Unrelated families have been grouped nearer. For example, Podostomaceae of series Multiovulate Aquaticae of Monoclinidae deserves a place in Rosales of the series Calciflorae of Polypetalae. Similarly, Larini of series Daphneales of Monoclinidae deserves a place in Ranellus of the series Thalamiflorae of Polypetalae. Thus, two unrelated families, Podostomaceae and Larini, are grouped nearer. The position of series Epicarpi is unsatisfactory due to its free and superior carpellus. However, in spite of all its disadvantages, the Bentham and Hooker system is still very popular in many countries because identification of plants in the field is comparatively easy. It is followed in the Kew herbarium for the arrangement of plant specimens, as also in many other herbaria, particularly those of the Commonwealth countries. Dear students, this is all about Bentham and Hooker system of classification. Dear students, we have discussed over here various silent features of classification system proposed by Bentham and Hooker. We have also discussed here merits and demerits of classification system proposed by Bentham and Hooker. Thank you very much. God bless you.